In this video, we're going to continue on with derivatives. So we're going to use the same derivative definition, this formula, to find the derivative or f prime of a at a specific value, and the formula for finding the derivative or f prime of x for any value of x on the function. Let's try this example where we're going to find the derivative of f for this function. So this is asking us to find f prime of x. So not at a specific value, but for every x for the function. So we have f prime of x equals the limit as h approaches 0. And our first part is going to be f of x plus h. So I'm going to replace the x with x plus h. So I have 2 over x plus h, and I still have the minus 3. Minus f of x is the next part, if you look back at the definition. So that means I leave it as 2 over x minus 3, right? I replace x with x. Still over h. So this is why I saved this problem. So I've got fractions within fractions, which we can do. All right, so we still have the limit as h approaches 0, and I need to simplify it so that that h in the denominator cancels. But the only way to subtract the fractions at the top is to give them a common denominator, which is going to be x plus h minus 3 times x minus 3. All right, so the first fraction needed x minus 3. So I have 2 times x minus 3. And the second fraction needed the x plus h minus 3. So 2 times x plus h minus 3, and all over h. All right, let's keep simplifying. So I'm going to put those two fractions together at the top. So the whole denominator of the numerator is, let's see, x plus h, whoops, sorry about that, it was instead x plus h minus 3 times x minus 3, and then when I do the numerators, I'm going to do all the distributing, but I have to be very careful, right? The first one, no problem, but the second one, I'm distributing negative 2. So negative 2 times all three of these. All right, so I have 2x minus 6, and then I'm distributing the negative 2. So negative 2x minus 2h plus 6. And I still have h in the denominator of all of it. All right, so the limit as h approaches 0, and if I can maybe do a little canceling, 2x minus 2x cancels, negative 6 plus 6 cancels. So we are left with negative 2h over x plus h minus 3 times x minus 3 all over h. And now, since we have one fraction in the numerator, I'm going to divide by the reciprocal, or multiply by the reciprocal for division, sorry. So times 1 over h instead of dividing by h. And we cancel the h's. All right, so I have to do my work over here on the side. So I now have the limit as h approaches 0 of negative 2 over x plus h minus 3 times x minus 3, and I can now plug in 0 finally for h. So when I plug in 0, I get negative 2 over x minus 3 times x minus 3, which is really just x minus 3 squared. So that is the derivative, or f prime of x. So the derivative of the whole function for any value of x. So I could actually look at the same function, and I could find the derivative of that function at x equals 1, and I have two options now that I've already found the derivative for any x. So I could start over the problem, and I could find f prime of 1, and I could use the limit as h approaches 0 of, and I'm going to do f of, it was a plus h, so it's going to be 1 plus h minus f of a, so f of 1 all over h. So I could do it this way. So the limit as h approaches 0 of, let's see, now I'm plugging in 1 plus h. So 2 over 1 plus h minus 3 minus 2 over, and I'm plugging in 1, so 1 minus 3 all over h. Alright, so the limit as h approaches 0, and I now have 2 over, let's see, that's going to be 2 over h minus 2 minus 2 over, let's see, what does that become? 2 over negative 2, so negative 1, so 2 plus 1 all over h. So my common denominator this time is h minus 2, so I'm multiplying that here, top and bottom, by the 1. So the limit as h approaches 0 of, let's see, common denominator we said was h minus 2, so I'm just going to put them together now. So 2 plus h minus 2 all over h. The 2 minus 2 cancels. So we now have the limit as h approaches 0, I guess, of h over h minus 2 times 1 over h, because I'm dividing by h, which is multiplied by the reciprocal. The h's cancel again. So we're ready to plug in. That's really 1 over h minus 2. We're ready to plug in 0. So we get the limit as h approaches 0 of 1 over h minus 2 is 1 over negative 2, or negative 1/2. So we just found that the derivative at 1 is negative 1/2. Now that's one way you could do it, but because we already found the derivative for any value of x, we can go back to what our answer was on the previous one. So we knew that f prime of x was negative 2 over x minus 3 squared, and I can just plug in 1 from there. So negative 2 over 1 minus 3 squared, that gives me negative 2 over negative 2 squared is 4, and so we find that the derivative at 1 is negative 1/2 again. Okay, so it really just depends on what you're given. If you hadn't done all that work already, then you'd want to do the work that we did in blue. If you had already found the derivative for all x values, then it probably would have been easier just to plug it in.